Let's go ahead and pick up where we left off yesterday. We were just getting ready to talk about quotients of complex numbers. And we're going to need to multiply by the conjugate. For any of these things, anytime it says simplify, I'm trying to think of the other set of directions. If it asks you to do operations with imaginary numbers, with complex numbers, our answers should always have the form of a plus bi. So until it looks like this, or sorry, there could be a minus there too. Until it looks like this, I'm not done. That's why on part A, I have to multiply by the conjugate because I need to get it in this form of a plus bi. All right, so I'm going to multiply my numerator. So I'm going to distribute the 4 to each piece here. So I have 8 plus 20i. What's going to happen down in the denominator? Remember, conjugates are like the factors that we get from a difference of perfect squares. What does a difference of perfect squares look like?
X squared and then a perfect square.
Yep.
Minus a perfect square.
Yeah, so something like x squared minus 4, and that factors down to what?
X plus 2, x minus 2.
X plus 2, x minus 2. So when we are multiplying by these complex conjugates, we're going backwards here. So I want something that kind of reminds me of a difference of perfect squares. Notice on my difference of perfect squares, there is no b value there. There is no middle term. That's why I'm multiplying by that complex conjugate. I don't want a middle term. I want whatever this first term is to get squared. I want whatever the second term is to get squared, and I know it's going to be subtraction in between them. So what will my denominator look like here? 4 minus 25, because it's 5 times 5, I squared. Beautiful. Can we simplify that anymore? What can I do? I squared equals -1. So that would turn that into a positive 25, right? So I have 8 plus 20i, oops, not 2i, 20i over 4 plus 25. So what is my denominator? 29. Does this look like this yet? It's very close, but it's not quite there. What would I need to do to this to get it to look like this? Not multiply. If I had two sides, I could. If I could do something to one side, then I could do it to the other.
Divide both numbers or values.
Yes.
29.
We're going to divide both the real part and the imaginary part by 29. So my final answer here, I would have 8 over 29. That shouldn't be a 2i, that should be a 20i. I apologize, I keep writing the 2 for some reason, but not the 20. Plus 20 over 29, and then I. If you leave the I in the numerator, that's not wrong, but for everything that we're doing here in class today, I'm going to write the I off to the side, because when you guys are doing the homework for 2-4, which is due on Monday, by the way, and you go to type in your answer, there will be a blank for this first piece. There will be a drop down so you can choose plus or minus here. And then there will be a blank for this, but I already have the I in there for you. So I do want you to enter this part as a fraction right there, and you don't have to worry about putting the I because the I is already there. All right. Talk to me about B. How can I make that one look like A plus or minus BI?
Multiply the whole thing by 3 minus 4i.
Yes. Multiply top and bottom by 3 minus 4i. My denominator is the easy part here. What will the denominator look like? 9 minus 16i squared. For the numerator, I'm going to have to use double distribution because now I don't just have a 4 that's being distributed. I have to double distribute, just like with a binomial. So I do 2 times 3 and I get 6. 2 times negative 4i, so minus 8i. And then I take negative I and distribute that as well. So minus 3i plus 4i squared. What can I simplify on this fraction now? 8i and 3i. Both of those are negative, so when I combine those together, I get what? I'm sorry, one more time?
Negative 11.
Negative 11, yes. Sorry, I just didn't hear you. So I have 6 minus 11i. What else can I do? I squared. That turns into a negative 1. So I have 4 times negative 1, which is what? Negative 4 or minus 4. Same kind of thing down here in the denominator. I have an I squared. So instead of my denominator being 9 minus 16i squared, I have what? 9 plus 16. Tell me what else I can combine now.
6 minus negative 4.
Yep, 6 minus 4. That would give me 2. So I have 2 minus 11i over what?
25.
Over 25. And then I want to write this in the form of a plus or minus bi. So what does my final answer look like then?
2 over 25 plus negative 11 over 25.
Yes, since it's that negative 11, I'm going to put a minus in between instead of plus a negative. But other than that, absolutely correct. And then I. Let's try this last one here, C. Tell me what to multiply by. Negative 2 minus I, yes. So I'm going to multiply the top by negative 2 minus I and do the same thing on the bottom. I know that means my denominator will be what?
4 plus I squared.
Close.
4 minus I squared.
It's always going to be minus in between because it's always going to look like a difference of 2 squares when I'm done with it. So 4 minus I squared. For my numerator, got to double distribute here. So I'm going to have negative 14i, or sorry, negative 14, my bad, minus 7i. And then minus 4i minus 2i squared. So up on top, I know I can combine these two together. I know this I is equal to negative 1, so that's going to change it to being a plus 2 there. So I have negative 14 minus 11i plus 2 all over what? Close. All over 5. Because I have 4 plus 1 down here. How does my numerator finish simplifying? Yep. I have negative 12 minus 11i, and so finally to write it in that complex number form, I get negative 12 over 5 minus 11 over 5i. How do you guys feel about this?
I got a question.
Yes.
I might be tripping, but the 4 plus, is that I squared or I to the third?
4 plus.
Like the,
Right here?
yeah.
That's an
Wouldn't
I
that be-
squared, because it's I times I.
Wouldn't that be, wait, maybe I'm tripping. Oh yeah, I am tripping.
Okay,
Thank you.
you're welcome. I love car alarms. They're great. They should make more cars with them. Sorry. Simplifying expressions. Part A. What can I do with that numerator? How could I rewrite it so it didn't look so horrible? Very close, yes. So if I was the one taking a square root of both sides, absolutely plus or minus. When that's what's given to me, unless the directions say otherwise, we assume that what they want is the primary square root. So in this case, I would just have it as being 6i. If you take the square root of both sides as part of solving a problem, you have to do the plus minus. But here, where they're just asking us to simplify what's already there, I can just write this as 6i. Yes, ma'am.
So if you're solving plus or minus?
Yes.
Or if you're just simplifying, it's just 6i?
Yep. Nice clarifying question there. If you're solving, and through the course of solving, you find that you need to do that, take a square root, then it would be plus or minus 6i. Yep. How can I clean up the denominator?
3i
3i
times 10i.
times 10i. So when I'm multiplying these two things together, we've talked before about how if things are under the radical, I can multiply those pieces together. But I always have to keep order of operations in mind. I don't want to multiply things together before I've tried to deal with the exponents. And remember, a square root is an exponent. And since it's possible for me to simplify this, I need to do that first. If I don't, I'm going to miss the fact that there's an I there. And that's a really important key feature. So in that numerator, I still have a 6i, but what happens on the bottom?
Multiply and then use the I or the I squared thing.
Yep. So I have 30i squared. I squared, though, is negative 1. So what is the denominator actually? Negative 30. Can I reduce that at all?
Yeah.
What can I take out of both of them?
6.
Yep, I can divide them both by 6. I normally like my denominator to be positive, and I like the negative to be up in the numerator. And so I'm going to divide these both by negative 6, so that I have my negative up on top instead of the bottom. It technically doesn't matter, but just as part of a math grammar thing, we never like to leave our negatives down in the denominator. They're too easily missed there. So I divide both top and bottom by negative 6. So what do I have in my numerator then? Negative 1 over
30 times
5. There's something I'm missing. The I. Where should that go? It can go on the side, like this. Or if you're doing this on a test for me, and you leave it as negative I over 5, I would accept that. When you go to type it in Canvas, you would want the negative 1/5, because remember, Canvas is already going to have the I there. Question. Are these in the form of A plus or minus BI? First one is. What is the real part, the part that would be where A goes? 0. If I was given this in Canvas and there was blank, and then I choose a plus or a minus from the drop-down and then a blank, it would be 0 minus 1/5 I. Because there is no real component here. In order for that negative 1/5 to be the real part, there would have to be either a plus or a minus sign in between that and the I. If you have a number multiplied to I, that is your imaginary component.
Can you show me sense.
Yeah. So I can take any number that you already know of and write it as a complex number. Give me a number, any number.
4.
4. If I'm going to write it in this form, there is no imaginary piece, right? So I would say that that is 4 plus no imaginary pieces, 0 imaginary parts. I can take any imaginary number and write it as a complex number. I could take negative 6i. Well, that one does not have a real part. It only has an imaginary part. So I can write that one as a complex number, or written in complex form as no real part minus 6i. Does that make more sense? Okay. All right. Example B. How can I rewrite that numerator?
7 plus 8.
Yep. 7 plus 8i. What about my denominator?
Negative 2 minus 9.
Negative 2 minus 9i. Absolutely. Is that written as a simplified complex number?
Not entirely.
Not entirely. So what do I still need to do to that so that we can write it as just a single complex number? Not yet.
I'll do the conjugate.
Conjugate first, yeah. Because if I want to distribute that division, I need the bottom to just be a real number. Yep. So I'm going to multiply top and bottom by negative 2 plus 9i. What will that give me down in the denominator then? 4 minus 81i squared, because it's I times I, yes. And then in the numerator, we're going to do our double distribution. So I have negative 14 plus 60, what is that, 63? I'm not really good with my sevens, I apologize. It's 63? Okay. And then I distribute here, so I have minus 16i plus 72i squared. I know anywhere I see an I squared, I can immediately replace it with what? Negative 1. So I'm just going to go ahead and replace those with negative 1s. And I can combine these like terms in here. So I would have negative 14 plus, is that 47?
Yep.
Okay. And then it's going to be minus 72 all over 4 plus 81. I'm going to combine the negative 14 and the negative 72. There's that negative 86. So negative 86 plus 47i all over 85. And now I can write it as a single complex number with a real part and an imaginary part. What will that look like?
Negative 86 over 85 plus 47 over 85.
Wonderful. Negative 86 over 85 plus 47 over 85i. Do you guys have any questions about this? So to conclude our conversation about complex numbers, we're going to use it when we're solving. So right here, I want to solve these two equations. They're both going to require the use of complex numbers. On part A, how do I know whether or not an equation is factorable or if I have to use the quadratic formula?
The X.
The X thing, yeah. So here I'm looking for two numbers that multiply to 13 but add to -6. Do you know of any that'll do that? No. Yeah, 13 is prime, so it's only 13 and 1 that I could try to make a -6 with. Here's another way you can learn or look at an equation and determine whether or not it's even worth trying to factor or if you should just give up and do quadratic formula. The discriminant of the quadratic formula, b squared minus 4ac, when you do that, if it comes out to be a perfect square, it's factorable. So I'm going to substitute into that, because you guys already told me this one doesn't factor, so I'm going to need this anyway. I always do this first when I'm doing quadratic formula. What are we putting in for b? -6. For a is 1, and c is 13. So I do -6 squared, that's 36, minus, what is that, 52? What is 36 minus 52? -16. This is what's going to go under the radical. And while 16 is a perfect square, -16 is not.
It'll go under what radical? Oh, okay.
In our quadratic formula. So I'm going to rewrite quadratic formula here.
Wait, so you said, wait, how can we figure out that that's, by using that, how can we figure out that that's like not going to work and you got to do quadratic?
Is -16 a perfect square?
No.
No. But if it had come out to be 16, is that a perfect square? Yes. Then we can factor it. If the discriminant, the part under the square root, comes out to be a perfect square, because it goes under the square root, you're going to square root it. If it's a perfect square, then you could have factored it. All right, so let's substitute into quadratic formula here. I only do substitution in 3 places in quadratic formula. I always find my discriminant first, because that's the part of quadratic formula that's a hot mess. That came out to be -16. That goes right under my radical there. And what do I put in the set of parentheses right after the negative sign? -6, and I put a 1 down in my denominator. So I've got my negative and my negative, so I'm going to have a +6 up here, plus or minus. Now, -16 is not a perfect square, but it does simplify, right? That would be the same as what? 4i. So I'm going to replace that with 4i all over 2. Now I want to reduce my fraction. This was actually something that I saw happen on the quiz a couple times yesterday. After you simplify your square root, you have to do that before you do this part, any numbers that are not underneath the radical need to be reduced. So I'm not only looking at the 6 and the 2, but I'm also looking at the 4 here. What will go into all of those? 2 goes into all of those. So how would this simplify then? 3 plus or minus 2i. How many answers? 2. 3 plus 2i, 3 minus 2i. Part B. Does anybody remember what that's called?
Difference of perfect cubes.
Close. It's not a difference because there's not a minus. Sum of perfect cubes, yes. You were so close. If I'm going to do a sum of cubes, I need to know the cubed root of each piece. So I need the cubed root of x cubed, which is x. This is going to be one thing that I use. And then I also need the cubed root of 125. 5. Those are going to be the A and B pieces that we talk about when we're talking about our sum or difference of perfect cubes. And then I use a word, an acronym, to help me remember my signs. SOAP. What's that stand for again? Yep, same, opposite, always positive. So my very first factor, I take the a and the b, so the x and the 5, and what goes in between them? Plus, because it is the same as whatever is here. So there's my a and my b. And then I get a quadratic factor. It's going to be a squared here, a times b in the middle, and b squared on the end. So what goes at the front of this? X squared, because x times x. Will I have a plus or a minus next? Minus, because it's the opposite of what we just used. Now I multiply those two pieces together. 5x, plus or minus here? Always plus here. And what are we going to end with? 25. Beautiful. They asked me to find the roots to solve this. For my linear factor right here, I can pretty easily do that, right? I take that guy, I set him equal to 0, and I know that one of the roots is where? -5. This other one we've talked about several times. That guy's not factorable. But now that I know about imaginary numbers and we've practiced using quadratic formula, I can find those roots. So I always find my discriminant first, the b squared minus 4ac part. So I'm going to take the -5 and I'm going to square it. Minus 4 times 1 times 25. So I have 25 minus 100. That gives me -75. Now I'm going to substitute into the whole quadratic formula. Right at the beginning, that's where I put my -5. Underneath the radical, what goes there? -75. And down on the bottom, we have just a 1. Negative and negative, so that turns into a +5 there. Plus or minus, and I have a 2 down here. The square root of -75. Is 75 divisible by any perfect squares? 25. 25 goes into it how many times? 3 times. So I have 3 times 25 times -1. That would all be -75, right? We know the square root of this, and we know the square root of this. Square root of 25 is 5. The square root of -1 is I. So this is going to be 5 square root of 3 I. Now here's one thing. Some people like to put the I right after the 5. If you do that, I'm not going to count it as wrong. When we write numbers that are imaginary, we always put this part first and then the I second at the end. If you put it in a different order, I'm not counting it wrong. Yes, ma'am?
What is the I squared?
Would you put I squared? No, because the square root of -1 is I. That's why when we have I squared, we get -1. Yep. Almost done. Is this written as a complex number? As a single complex number? How do I write it as a single complex number?
Multiply the top and bottom.
Close, not multiply.
Divide everything by 2.
Divide everything by 2. I'm not going to multiply top and bottom by anything here because that's not going to help me simplify it. So I would have 5/2 plus or minus 5 square root of 3/2, and then I at the back. How many roots did we just find on that problem? 3. 1, 2, 3. I knew at the beginning of this problem that there were 3 roots. What's the highest exponent? 3. That gives me the maximum number of roots I can have. So I always know if I've done enough. If I end up with that many, then I know for sure I've found them all. Do you guys have any questions for me about complex numbers? Yes?
For B, how do you get negative 5 and not positive 5?
For here?
No, for whenever you plug it in for B squared minus 4AC.
Oh, I grabbed it from right here. Sorry, math is reusing some terms here. If you look in your book and they talk about the sum and difference of cubes, they refer to them as the A term and the B term. But that does get a little confusing because when we're talking about quadratic equations, we have our A term, our B term, and our C term. Does that help? I apologize for the recycled notation. I wish your book used something different there. All right. Do you guys have any other questions for me about complex numbers? All right. Yes, ma'am.
So when there's a binomial in the denominator, you do the conjugated to the rest, right?
Yep, absolutely. If you see a binomial or something that looks binomial-like, you can multiply by the conjugate and get rid of it. All right, we are going to go ahead and start briefly 2.5. Your 2.4 homework is due on Monday. 2.5 is other types of equations. So we've talked about all kinds of different types of equations so far. All of the tools that we have reviewed or learned between chapters 1 and chapters 2, all of those things are fair game as tools as we move forward. Do you guys remember absolute value? What does absolute value mean? The distance from 0. And what do you know about distance? Yep. Never a negative. What's inside the absolute value stuff can come out to be negative, right? But the effect the absolute value has on it is if I find a negative on the inside, the absolute value will turn it into a positive. So if I'm trying to figure out what x is, I know that x plus 7 is equal to either positive 9 or it could be a negative 9 on the inside, right? So I'm going to need to set up and solve two different equations to figure out what x could possibly be. I need to do x plus 7 equals negative 9, because that's one possible value for x that would make this true. You okay?
Yeah.
Okay. And x plus 7 could also be equal to positive 9, because that would give me the same absolute value either way. Then I'd want to subtract 7 from both sides. So x could be what? Negative 16. Let's check that and see. If you take negative 16 and you put it in the place of x, negative 16 plus 7? Negative 9. The absolute value of negative 9? Checks out. Over here, I'm going to subtract 7 from both sides. So x could also be 2. That would also make it true. What do I do on something like part B where it's not just my absolute value? Simplify. I need to isolate the absolute value. So there's two pieces outside the absolute value. There's the 3 in front of it, and then there's the minus 8 on back. What do I get rid of first? The minus 8. So we're going to add 8 to both sides. So I end up with 3, and then absolute value of x minus 4 is equal to 10. How do I get rid of the 3? Divide. It's being multiplied to my absolute value right now. So I'm going to divide to make it cancel. So I have the absolute value of x minus 4 is equal to 10 thirds. I know that that means whatever's inside here is equal to positive or negative 10 thirds. And then I can set up and solve two separate equations. What do I need to do on both of these? Add 4. Should I leave an answer as 4 minus 10/3? Would that be fully simplified? Okay, so I need to write it with a common denominator here. What should my numerator be if the whole thing should simplify to 4? 12. So x equals 12/3 minus 10/3. So what is x? 2/3. 12 minus 10 would give me 2. So 2/3 is one of the solutions here. For the next one, 12/3 plus 10/3 would simplify to what? 22/3. What do I do on C? Add 4 to both sides. So I have -2 absolute value of x plus 8 equals 10. And then divide both sides by -2. So I get the absolute value of x plus 8 equals -5. What do I do after that? What's absolute value mean again?
Distance from 0.
Distance from 0. And what do we know about distance? It can never be negative. What do I have it equal to right now? Is that possible? This can't happen. So what's my answer? No solutions. No solutions. We're going to do these factoring by grouping problems, and then we will call it a day. I don't know if we'll get through both of them, but we're going to get through at least one of them. I still want to be able to have you look at your quizzes. Factoring by grouping has to be equal to what? 0. Must be equal to 0. So we're good to go to start this one. I'm going to make my 2 groups, first 2 terms, second 2 terms. What's the biggest thing I could pull out of those first 2 terms? 9x cubed. What would that leave me with? Oh, x squared, I'm sorry. My apologies. I heard cubed first, and so I went with it. 9x squared. So I have an x and then what? -2. I know that that's what I need to have left from my second group. So what can I take out of the second group so that I have an x minus 2 left over? -4. That would leave me x minus 2. Those have to match, or else I can't use factoring by grouping. So one of my factors, only one factor, is x minus 2. The other factor would be 9x squared minus 4. Is that fully factored?
No.
What can I still do? Yes, this is a difference of 2 squares. So I have x minus 2, and how will that factor over there? 3x minus 2, 3x plus 2. What do I do with each of these factors now? Set them equal to 0. So give me one of my solutions. X equals 2. Give me another solution. X equals 2/3. And the last one? X equals -2/3. We will do the other factor by grouping problem on Monday as we continue to 5. If you would like to see how you did on the quiz from yesterday, please come up and see me at my desk.